Well, we have another question here, question 4. The question says, in the diagram, M is the center of the circle through T, R, and S. RT is a diameter of the circle. K is a point on the fourth quadrant such that KTL is a tangent to the circle. Now, question 4.1, I'm going to write the question here. 4.1 says, okay, let's question 4.1 over here says that give a reason why TSR is equal to 90 degrees. Well, so we need to prove that TSR equal to 90 degrees. Okay, there's a property that says something about the semicircle. You can see this is a semicircle because we have a diagonal passing through the center. So the property says that angle at the center in the semicircle is equal to twice angle at the circumference. So we know that this is a straight line, which is 180 degrees, okay? And then this angle over here must be 90 degrees because 90 degrees times 2, okay, makes 180 degrees. So I'm gonna say here, in the semicircle, okay, angle at the center equal to 2 times, okay, let's just say 2 times angle at the circumference, or angles at the circle. Now that was 4.1, okay, and then the following question is question 4.2. Well, the question says calculate the gradient of TS. Now right here 4.2. So I need to find the gradient of TS. So M TS, and we do know that the gradient M is given by y2 minus y1 over x2 minus x1. Now MTS will be equal to 2 minus 7 over 5 minus 3. So this will make MTS will be equal to -5 over 2. So that's the gradient, MTS. Okay, and then the following question is question 4.3. The question says determine the equation of the line SR as the equation of this line over here. Okay, when I look at S, I can see the coordinate of S are 5 and 2, and R coordinates are not given. Okay, just gonna say XR and YR. So let's first start by writing the question here, 4.3. So we're looking for the equation of the line SR in the form y equal to mx plus c. Okay, let's first erase what is here. We did say it previously that this is a 90 degrees angle because it's 90 degrees angle because this is 180 degrees. Now that I don't know the coordinate of R, I can use perpendicular lines, okay? Because we know that perpendicular lines are 90 degrees, okay? Forms an angle of 90 degrees, I mean to say. And that we also know that the gradient, let's write it here, the gradients of perpendicular lines equal to -1. So the gradient in the first line here is of the gradient of TS, okay, is equal to negative TS here is equal to -5 over 2. So we're gonna do actually I prefer to write this way. So we're going to prove that the gradient of TS times the gradient of RS or SR equal to -1. Now, in the previous question over here, we did find the gradient of TS, which is -5/2. So here we have like -5/2 times the gradient of SR, which is equal to -1. Now, if I need to calculate this, I can times this side by -2/5. Okay, the inverse of this. Okay, and then times that also by -2/5. Times here by -2/5. So and then this will make, okay, we can see that the negative signs here will be cancelled out, and then 5 and 5, 2 and 2. So this means cancel. So we have left with 1. Okay, everything is cancelled, just 1 times MSR, which will be equal to +2/5. Therefore, if I can move, okay, just move a little bit up there. I say therefore, MSR will be equal to 2/5. Now, now that we find the gradients, we can substitute in the form, in the equation of the line there, okay, which will be y will be equal to 2/5 x plus c. Now we can sub in the points. The only given point is the 0.52. I'm gonna sub 2 for y and 5 for x. So this will be a sub 2 for y and then 5 for x. So this will be like 2 equal to 2/5 x plus c. Okay, and then we can simplify 5 and 5 here, and then if I move, we have like 2 equal to 2 plus c. So if I move the 2 over, okay, 2 minus 2 equal to c, and then c is equal to 0. Therefore, the equation of the line then, therefore, the equation of the line will be 2/5 x. So that's the equation of the line SR. Right. Now, that was question 2.2, and now we did 2.3. I mean 4.2 and 4.3. And now we're going to do question 4.4. The question says the equation of the circle above is given by, as we can see, x minus 9 to the power of 2 plus y minus 6.5 to the power of 2 equal to 36 and the quarter. Now, question 4.4.1 says calculate the length of TR in third form. So we want to find 4.4.1 says calculate the length TR. So you want to find this length here. But in third form. Third form means we need to leave the square roots, okay? We need to leave out the square root. Okay, so how can we do that? We know, you can notice that TR here is just the diameter of the circle, okay? And then the diameter is twice the radius. And then from here, we can work out the radius of the circle and then times it by 2, okay? So I'm gonna move my board over here. Let me just split it like this. I think I need to reproduce the same diagram. Let me write here 4.4.1. 4.4.1. Let me just do the diagram. All right, I'm gonna place the diagram over here. So in the question, it is said that the equation of the circle is given by x minus 9 to the power of 2 plus open brackets y minus 6.5 to the power of 2 equal to 36 and a quarter. Okay, so I said the general form of the circle is x minus a to the power of 2 plus y minus b to the power of 2, and this is equal to r squared. Now we can see that this is just the radius of the circle, okay? The radius is 36, and then we do know that from the question, because we need to find the length TR is twice the radius, which is the diameter, okay? So if I say r squared equal to 36 and the quarter, I can work out r will be square root of 36 and a quarter, okay? We can use a calculator for that. And then square root of 36 and a quarter. Okay, not that, not that way. How can I write it again in the calculator? 36 and 1/4. Can I do that? Okay, I'm struggling to write that this way. Okay, anyway, I can just simplify over here. So R will be 36 and the quarter is like 4 times 36, which is 144 plus 1. So that makes 145/4. Yes. Now I can just do square root of 145/4 equal to, so R is just square root of 145/2. This is R. Now the radius, this is R halfway. So this part is root 145/2. And that also, the other side, just so root 145/2. So if I need to find the diameter, then the diameter will be 2 times R, okay? Therefore, the diameter, which is T, the diameter equal to square root of 145. Therefore, TR is just square root of 145. Okay. In the following, okay, now the next question is question 4.4.2 says calculate the coordinates of R. Okay, so the coordinate of R is this one. So I'm gonna move my board like this, like that. So we're doing 4.4.2 that says the coordinates of R. Okay, let's first we can put the diagram over here. I want to place my diagram over here. Okay, we need to find the coordinate of R, x, y there. What do we know from the question? It is given that the circle, the equation of the circle is this one. Okay, so that this means that the center M has coordinate 9 and 6.5. Okay, so over here, M coordinates of M are 9 and 6.5. 9, 6.5. That's the coordinates of M. So we can use M is the midpoint, okay, of TR. Okay, so we can use the midpoint formula to find R. I'm gonna say M the midpoint, which is given by x1 plus, okay, I prefer to write this way. XM the midpoint, the middle, the x coordinate of the midpoint will be x1 plus x2/2, and then ym will be equal to y1 plus y2/2. Now we can find then okay, because we know M, the xm is 9, okay, 9 there, and then ym is 6.5, so I can write m here. M will be 9 equal to x1, which is 3, plus x2 is our xr, okay, over 2. And then over there, we have like 6.5, which is equal to y1 is 7, and then y2 is yr all over 2. Now, in the brackets, I can just drop the brackets and everything. We couldn't cross multiply because over here, it means the denominator is 1, okay? So if I just take 9 over 1 equal to 3 plus xr over 2, we can times this with that, and then 1 with all these. So this will make what? 3 plus xr equal to okay, times 1 equal to 9 times 2. So that makes 3 plus xr equal to 18. If I move the 3 over, that would be xr equal to 18 minus 3, and then xr equal to 15. So I have xr. Over there, 6.5 can be written as 13 over 2, okay? 13 over 2, and this is equal to 7 plus yr over 2. So how did I get 13 over 2? I did 2 times 6, 12, 12 plus 1, 13. I write 13 over 2. Now in this situation, we can just, we are allowed to just drop the denominator, and then we'll have like 13 equal to 7 plus xr. And then I move the 7 over, and then this will be 13 minus 7 equal to xr, excuse me, yr, and then that makes 6 equal to yr. Therefore, the equation is, the coordinate of r is 15 and 6, that r. Well, that's 4.4.2. Now, the next will be 4.4.3. The question says calculate sine r. Okay. Right. I'm gonna move again my board to the other side, and we have like question 4.4.3. So we're looking for sine r. Now I think I can also place in the diagram over here. Here's the diagram. So we're supposed to find sine r. Okay. What we know, by definition, sine of the angle is equal to opposite side over hypotenuse. Okay, over r. Let's just do over r. Opposite is y. Okay, so that's opposite over hypotenuse. Okay, so in this situation, sine r will be the opposite side is opposite of the angle. Okay, opposite is the line TS over hypotenuse is TR. Now, we already know what TR is because we did work it out in the previous questions. TR is the diameter of the circle, the square root of 145. Let's double check. We did it somewhere. Yes, TR was square root of 145. Now, okay, you know, TR is root 145, but TS is still unknown. Now let's find TS, because we can find TS because you have like the 2 points there by the help of the distance formula. D is equal to square root of x1 minus x2 to the power of 2 plus y1 minus y2 all to the power of 2. So the length TS will then become 3 minus 5 squared plus 7 minus 2 squared. Okay. Apparently I did it. I don't know if I don't remember if I did it somewhere earlier. That makes 4 plus 25, and then this is 4 plus 25. I don't think I did it. So TS will be equal to square root of 29. Now we can solve sine R by applying this property. So therefore I can say therefore sine R will be TS over TR, so root 29 over root 145. So this can be written as sine R will be equal, can be written like this within one square root, so 29 over 145. So that's sine R. Et voilà. Then the other question is 4.4.4. The question says that show that B equal to 12A minus 29. Okay. To show that B equal to 12A minus 20. Okay, B is over here. It is equal to 12A minus 29. Move board over here. Nope, not that way. 4.4.4. The concept show that B equal to 12A minus 29. All right. Okay, here's the diagram. So how can we do that? Okay, we can see that this line here is tangent, okay, to the circle, and then this is the radius, or this is the radius. Okay, we know from the theorem that the radius and the tangents are perpendicular. Okay, this we know that the gradients of the tangents. Okay, no, first I'll say this: the radius is perpendicular to the tangents. The radius of the circle is perpendicular to the tangents to that same circle, and then this implies that the gradients of the radius, okay, times the gradients of the tangents equal to -1. Now let's work out the gradients of the tangents. Okay, before we do that, we know the formula of the gradient is y2 minus y1 over x2 minus x1. Now work out the gradient of the radius first. Over here we did, M was given, okay, the center of the circle, it was 9 and 6.5. okay, so we can work out, we're gonna do 6.5 minus 7, the change of y, over the change of x, 9 minus 3, and this is equal to 13 over 2 minus 7 over 6, and MR will be equal to 13 over 2 minus 7 is equal to a half, -1/2 actually, over 6, and that makes MR will be equal to -1/12. How did I get it? You know, it's like having a fraction over another fraction. So this is the denominator of 1 there. So we will take a half times the inverse. Okay, I'm gonna do it here. It's like negative a half over 6. So I say that here it has a denominator of 1. So a fraction over another fraction, what we do, we take the first fraction, negative a half, times by the inverse of the other fraction, 1 over 6, and then the product here makes negative 1 over 12. Okay, so we got the m of the radius. Now let's work out also the gradients of the tangents. The gradient of the tangent, we have a point here. Now we know, okay, we don't have another point here to say, to use in order to find the gradient of the tangents following this formula. But we can use the previous formula here. Okay, then, so now this is what we're going to do. We're going to do mr times mt equal to negative 1. And we know that mr is negative 1 over 12, okay, times mt equal to negative 1. So now what we're going to do, let me split it like this. We're going to do this. We have like negative 1 over 12 times mt equal to negative 1. Now I'm going to times here by 12 over negative 12 over 1 in order to cancel this fraction. You understand? I do the same also on the other side, negative 12 over 1. Because 12 and 12 will cancel, negative and negative will cancel, and then I have left with the coordinates of the tangent only. This will be equal to positive 12. Then, now that I've got this gradient, I can work out the line, the equation of the tangents, the line that passes through the point T. Okay, let's say, let's do this. Therefore, the line y is going to be y equal to 12, okay, x plus c. Okay, that's the equation of the line of the tangents here. So we can find c if I sub in the point t. Okay, the point t there, so going to be 7 for y and then 3 for x. So 7 for y and then 3 for x. This will be 7 equal to 12 times x plus c, make 7 equal to 36 plus c. So if I move, excuse me, if I move the 36 over, and that's going to be 7 minus 36 equal to c, this means that c equal to negative 29. Therefore, the equation of the tangent is 12x minus 29. Now, okay, over here, I had like the point, the x coordinates of the point K is A, okay, and the y coordinates is B. So, therefore, if you sub that point, then we have like B equal to 12A minus 29, because this is the y coordinate B, and then the x coordinate is A. Proven. Okay, the next question is question 4.4.5, I guess. We have 4.4.5. Well, the question says that if TK is equal to TR, calculate the coordinates of K. Okay, if TK equal to TR, calculate the coordinates of K. Let's see. Now move my board over here. Let's move it. Question 4.4.5. So let's say if TK equal to TR, and then we want the coordinates of K. And then I prefer to put my diagram over here. Yeah, okay, this is the diagram. Now, in the previous, excuse me, in the previous questions, we did work TR, the length TR, okay? TR was calculated square root of 145, okay? And then we also need to find now the length. Now the question says if the two are equal. Okay, if the two are equal. Okay, this simply means, okay, we know the distance formula. I'm gonna write it over. So the distance formula is given by x2 minus x1 squared plus y2 minus y1 squared. Okay, now TK then will be square root of A minus 3 to the power of 2 plus B minus 7 to the power of 2. Okay, so but previously we did prove that B was equal. We did make B subject to the formula. We make it like 12A minus 29. So we can substitute the value of B by 12A minus 29 here. So this will be like, let's say, square root of A minus 3 to the power of 2 plus B. Okay, instead of B, I'm gonna write the value of B, which is 12A minus 29 minus 7 to the power of 2. Okay, so I can just move the little bit there. So now we can continue and then say this is like square root of A minus 3 to the power of 2 equal plus what's 12A minus 36 to the power of 2. Now, since it is said that since TK equal to TR, we can just equate them, okay? So it means square root of A minus 3 to the power of 2 plus 12A minus 36 to the power of 2 equal to square root of 145. Now we have square root both sides, okay, of the equation. We are allowed to remove the square roots. In other words, we raise both sides to the power of 2. The square root will be cancelled out, and then we have left with A minus 3 to the power of 2 plus 12A minus 36 to the power of 2 equal to 145. Now, I don't need to put plus minus because length, distances are always positive, okay? So over here, we can expand this part. So this is like, okay, I think I need to move my body a little bit this way. A minus 3 to the power of 2 is like doing A minus 3 times A minus 3, okay, plus 12A minus 36 is like that. 12A minus 36 equal to 145. Okay, the reason why, maybe I should mention it. The reason why I substitute the value of B here is because the value of B by 12A minus 29, as we did previously, it's because with one unknown in one equation, we can work it out. If it was two unknown in one equation, it won't be possible to find the solution. Now that we have like one unknown, A, that's okay. So we can times here is gonna be A squared, because we do actually A times A, sorry, let's mix A times A and A times 3 and then negative 3 and then like that. That's what we're gonna do. Yeah, you know, like that, that and that, and that and that, you know. This will be A squared times negative 3A plus 9, and then that's gonna be 144A squared and then 12a times negative 36, I can do that in the calculator. 12 times 36, that makes 432. So that makes negative 432 minus a, and then another minus 432a again, because okay, negative 36 times 12a, and then 36 times 36. Oof, this is 6. I don't know. 36 times 36. I was so wrong. 1296 plus 1296 equal to 145. Now, we can solve this by combining like terms. The terms with a squared are like preferably underlined, okay? So we do the a squared and another term with a squared. Yes, this one. Those two makes 145a squared. Terms with a, we have like this, that, this, and that. They can be combined together. If you're unsure, you can use a calculator. This would be like negative 3, negative 432, negative 432. Okay, and then this is equal to negative 870. So negative, that makes negative 870a. And then plus 1296 equal to 145. Now, if we move the 145 over, okay, this will be minus 145. Okay, and then so I do 1296 minus 145. This is 1151. So I don't need to write all this, but you know, this is 1151 equal to 0. Now we can solve this by using the quadratic formula. Okay, am I correct here? Let's see. Oh, I see. I missed this one, even though I underlined. Okay, I missed the positive 9. So plus 9. So if you do 9 plus this, it makes let's do this. 1296 plus 9. This is equal to 1305. So over here it's 1305. 1305. So let's just erase this. So we have like 1305 minus 145 equal to 0, and that makes 145a squared minus 870a, and then 1305 minus 145, this is 1160. So plus 1160. Okay, it's gonna be a lot of work to factorize over here. So the easier way to solve this is to use the quadratic formula. Remember, the quadratic formula is like, I'm saying quadratic formula because we have like a square there, and then it is of the form ax squared plus bx plus c equal to 0. And whenever we have like this form, we can use the formula x is equal to negative b plus minus square root of b squared minus 4ac. Okay, my root was too long. All over 2a. So in this situation, our x is a, so it's going to be a will be equal to negative b, which is negative 870, okay, plus minus square root of b squared, so negative 870 squared minus 4a which is 145, okay, times C, which is 1160. Okay, like that, all over 2A 145. So we can just enter these values in the calculator just as is there. So it's gonna be like minus open brackets 870 close brackets, and then plus square root, then square root, that's gonna be negative 870 raised to the power of 2, and then minus 4 open brackets 145 close brackets, open another bracket 1160 close brackets, all over 2 open brackets 145 close brackets, and then this is equal to negative 2. We have like A equal to negative 2, but this one is for with the positive here, and I'd like to also work out with the negative. This will be, because remember this will generate oops, I was a bit fast, the calculator there. And then that was with the positive. Now with the negative, enter, that's negative 4. Put A equal to negative 2 or A equal to negative 4. Now, let's see in our diagram over here. I can just paste in the diagram there. Okay, maybe I can just move my. Okay, in this diagram, if we look at why am I getting negative? Because it's positive here. Did I enter the values correctly? Oh, I think I didn't put. Okay, let's see in the calculator. Yes, I didn't put placing the negative over here. My bad. Okay, because I know they're all in the first quadrant, so it must be so negative there. When I hit equal, yes, A is equal to positive 2. And then if over here, positive there, and then hit equal, we have like positive 4 also. So like A is equal to 2, or A is equal to positive 4. Now, if I need to find then the value of B, remember, we did say that B was equal to 12A minus 29, okay? So I'll keep it there. Now, if A equals to 2, B will be equal to 12 times A minus 29. A is there. A is 2, sorry. And then this will be, B will be equal to 24 minus 29, which is equal to negative 5. Okay. And then if A equal to positive 4, B will be equal to 12, open brackets, there, minus 29, 4 there, and then 12 times 4 is 48. 48 minus 29 is equal to 19. So B will be 19. B will be equal to 19. Now, over here we have the points. K is the point when A is 2, B is negative 5. Okay, and there we have the points when A is 4, B is 19. Now, if you look at our diagram, maybe I should place in the diagram in this space here, so I don't move the board all the time. So in our diagram, we can see that K is underneath the x-axis, okay, in the third quadrant, where the y value is negative, Okay, this side the y value is negative. Now, therefore, the solution is k is 2 -5, and that one is not applicable. Not applicable. Thank you.